So it's become pretty clear that we need to think more about distributed block building in order to make sure that we can do like our upgrades with PRDAS and what comes after smoothly, and like at the same time not harm self-builders who like currently, I think like we agree that we want to very strongly push to be able to keep them around because they enhance our censorship resistance. So I think like some ideas have been floating around for quite a while on this, and like in a way it's like always been clear that this is possible. Like even when I first published my little summaries on dank sharding back 2 years ago, like I was trying to figure out how this could work, but so far we haven't really put on the full design and engineering work, and I think like we should do that now so that we come up with a good scheme. We make the necessary changes to the interfaces, and then like we actually like build it so that we won't have to worry about self-builders anymore. So I think like an important outcome of, I guess, the series of calls, especially the first few, would be that we try to decide on a version of self-building that we want to encourage. I think like one thing that's definitely become very clear is as long as we're keeping the mempool around, which I think like currently we have no intention of changing, then like we can use the mempool for like doing a lot of the work for self-building. I think that part is obvious. I think like the only part that's really missing right now in order to enable people to send the samples is to have the proofs around as well. And so there are a few different ideas. Like one way that has been discussed that I don't want to completely dismiss would be to add the proofs to the transaction itself, like create a new block transaction format. Yep.
Real quick, sorry, I'm not sure if you're actually screen sharing right now. It's blank for me.
I am. Oh, interesting.
It's blank, yeah.
Okay.
Black screen.
I am, but I haven't really started talking about what I'm sharing yet. So
okay.
I guess let me try that again then.
To be clear, we can see your screen, like the notifications and the bottom bar. We can't see the like what you're trying to show us.
Okay.
In the middle.
Makes sense. Right. Cool. So I was saying, let me continue while I reshare this. That like we can clearly add the proofs to the transaction format. That would solve the problem for the most part, because then anyone who has a transaction or who has the mempool transactions for the current block can always create the proofs for each column, which is one sample. The downside that I see with that is that we now will tightly couple the transaction format to our data availability layer. And I think like I don't see that as a great option for the future, because like we will make more upgrades to this regularly. And it just tends to be that transaction formats, because they are not just in the clients, but leak into the application layer and leak into like obviously whoever creates the transactions, that like it will be much harder to make upgrades in the future if we accept this. So one idea that I wanted to share was a note that I wrote up last week. Can you see my screen now?
Yeah, perfect.
Yes.
Okay. Where we do distributed computation of those proofs. And so the idea is this, that we create an additional gossip subtopic where any nodes that want to participate in this can gossip the sample proofs for transactions in the mempool. This is like not a huge overhead, like the proof size is about 6 kilobytes the way we've designed it right now. So we're not talking about huge amounts of data, given that the sample, the blobs themselves are 128 kilobytes. And so basically any node who sees a transaction mempool can do this. And then anyone can use these proofs to create a column sample. Like any node that is subscribed to the gossip subtopic for one sample, which is one column, can now just take all the blobs out of the mempool plus the proofs it has gossiped on this topic, and it can distribute the sample plus proofs for that. So this is like truly distributed. It doesn't really make any assumptions about any nodes like having like a whole network view or anything like that. But it does rely on that all the transactions are in the mempool, which is like kind of like something we have to talk about in the future as well, how we redesign the mempool. So the implementation would need that we like add this gossip subtopic. We would add a new endpoint to the execution endpoint engine API that allows the CL to poll for any new blobs. And then when we see a new blob, we let each node decide on the random day after which we will build a sample proof for the blob if it hasn't seen them on gossip yet. And all nodes can now participate in this sample and proof distribution by using the sample proofs from the gossip subtopic. So yeah, I mean, I think this is the first item on the agenda. So like I guess I'm curious, like especially from the client team, how they see the difficulty in doing this, if there are any blockers. If we should go ahead with this proposal, or if they prefer another version. Portus, do you have your hand up? Do you want to say something?
I wanted to ask a naive question about the previous approach of having the proofs on the transactions. So I understand that if this leaks into tooling, this is a killer if the transaction itself needs to carry the proof. But I don't understand what's the downside if you have by default, so you have a flag on full nodes that allows them to, whenever they see a transaction, to import transactions without proofs. And if they see a transaction without a proof, attach it and gossip it with the proof. So this way, whomever sends a transaction from a wallet, say MetaMask, the MetaMask runner, the RPC server of that one would do that. And I think most transactions would come, unless they're spam, they're going to come already with a proof.
Right. I think like this has also been suggested. So an alternative to this is, I think like if we could even do this like mandatory, where simply the execution layer, as soon as it sees the blob transaction, like the interface stays the same, but like the gossip changes. So the gossip would now only be transactions with proofs. I think that's doable. Like that wouldn't change the way that applications construct transactions. So I guess that's an advantage. It does still leak the whole proof construction and verification into the execution layer. So that's like one little thing that I don't like about it. But I guess like we should also discuss that as an alternative. Okay, everyone's so quiet here. So I am curious how people think about this. Maybe like everyone who has an opinion on this, like should, yeah, Ansgar?
Yeah, just briefly wanted to say on this that it does feel like the version where it basically is attached on the EL P2P layer already is, to me, somewhat simpler because it kind of travels together and you don't have to think about these on separate layers. So the main trade-off really seems to be the bleeding the proof computation into the EL. I would really like basically specifically maybe for EL people here on the call, if they could give some feedback on to what extent they would, like how valuable would it be to try to keep this piece of cryptography out of the EL, right? Because if it's important, I think actually your proposal of this of basically this more pure approach, I think is very sensible. But if it turns out that maybe this doesn't matter and it's fine to just have it bleed into the EL, yeah, then I personally would prefer that approach.
Wait, Ansgar, wasn't the whole point of not having it bleed into the EL is that it's an abstraction leak? So I mean, even if ELs don't mind it being there, isn't it just sort of a bad practice because ELs don't care about the proofs?
Well, I mean, they would care, right? Because then, in that sense, they would care also because it's something they check as part of the Mempool propagation. But yeah, there's of course also two variants, right? There's the variant where the EL just actually understands proofs and can generate them and verify them, or there's the version where the CL just exposes functionality for that, and the EL just talks with the CL back and forth. I don't know. I don't have strong opinions on the philosophical side.
We don't really have an API for asking the CL to do something. Right, that's one of the problems we're facing with all of this. That would be completely new.
Yeah, I guess it does seem a bit wrong if the EL is now needing to know about what this proof, like having to verify the proofs as well. Like, to me, it seems like a CL specific concern.
Right. Yeah, we have already done we have already committed a little bit that sin in that we have these proofs that allow us to verify the blob data quickly, because we did want that in the mempool. But yeah, I mean, this would go much further and would tightly basically couple our proof format between EL and CL, and it's kind of like we're losing a lot of the abstraction there.
Right. But I mean, I can also take the other side on this, right? So like just to spell out. So if we basically try to prevent this and we go with your proposal, that means that now the proofs travel separately on the CL side. And so that means, so I assume, I mean, maybe you can clarify, I assume that they would not actually, like no node would actually forward and broadcast these as they arrive. They would basically wait to confirm that there's a corresponding valid transaction in the EL mempool. Because otherwise you have this kind of this DOS issue. But now basically that means that you have this kind of weird, like somewhat weird tight coupling there, where basically now the CL basically has to like pull the EL for mempool updates, and then basically so two things that conceptually belong together are now basically broadcast separately, but then always have to wait for each other. Which I think that's the cleanest you can do it. I think this is the proposal is really clean, but it's the cleanest you can do if you really want to keep it on the CL side.
Right. Yeah, at the cost of extra latency. But I think like the question is, does that latency matter that much? Because most transactions will be like sent well before they need to be included, so we have time.
But okay, so then a question, for example, right? Like we are separately, we maybe talk about this later in the call, but we also will talk about like a potential sharded mempool design or something like this. So now the EL actually basically has logic that defines which of their peers will be interested in which transactions. But now the proofs are broadcast on the CL side, which does not understand that logic. So now basically you have this extra overhead where every node on the network will hear about every proof, even though they are only interested in a subset. So now all of a sudden the ratio of like data-wise, size-wise of proofs to blobs becomes less favorable, right? So this is kind of the type of, to me, that's basically the other type of abstraction leak, where basically now the CL in a way becomes part of the mempool in some weird way.
I guess my question is, if we could redesign from scratch, like what would this perfect system look like? Like would the CL just be computing even the current proofs that the ELs are doing? Because maybe we can take some short-term pain for the long-term benefits of where we eventually want to go.
Right. I mean, I think like if we think about long term, I think the weird thing is that we have two different peer-to-peer networks, right? The EL has an independent network from the CL, and that is basically just historically, right? Like we could, like if we had designed everything with the abstraction in mind that we want to separate the two, then we would like have from the beginning had only one of the sides have a peer-to-peer network, and the other would just be like feed off that peer-to-peer network. So I think like this is like kind of like maybe we should think that long term the mempool should actually be in the CL, because we should eventually just like deprecate the old peer-to-peer network. But I don't know like if we're ready to do that. Like right now there's still lots of things happening on the EL network. Dapline, you want to say something?
Yeah, sorry, I'm at the gym. Sorry for the noise. In PRS2D, will this strategy be viable? That could we not have the requirement to go PBS if we succeed in having distributed block building?
So with PRS, would the requirement be to do PBS? This is what we're trying to avoid.
Okay.
Yeah, distributed block building tries to do it so that like you can still build blocks at home. Marius, you're saying there's 1 gigabyte of blob transactions in Mempool. What are they doing there? Why are they not being included?
They're just chilling there. I have no idea.
So they're not paying enough fees.
Yeah.
Right.
How can you not pay enough fees if the minimum fee you have to pay right now is 0?
I don't know.
Well, probably the normal base fee, not the blob fee.
Yeah.
I mean, that sounds like a problem. If you get, I mean, that also, doesn't that mean you could send a gigabyte of data to all nodes, like, and flood their peer-to-peer connections?
Yeah, I think in general,
No, you only ever advertise the hashes of these transactions, and
Right.
the nodes will fetch them themselves.
Okay.
So
Right.
the node decides
And
to
that's-
overload itself.
That's rate limited.
Yeah, and also we never announce them.
Right.
We only ever announce new ones. We never announce the ones that we have in the database.
Right. Interesting.
By the way, it used to be 10 gigabytes, but I got Peter down to 1 gigabyte.
Oh, like as the size limit for the mempool.
Yeah.
Is that the size limit? I see. Interesting.
We were very proud that we could do 10 gigabytes, so that's why we kept to 10 gigabytes for a long time. But when it came to the fork, I was like, it's not a sane limit. Let's just do 1 gigabyte.
Wait, is POTUS, is your hand up?
Yeah, I wanted to
Oh, sorry. Yeah.
push slightly on this issue of if we were to design everything again, we would have only one P2P. And in fact, we're trying to actually separate even for syncing, to separate the blocks. Like if anything, we would want to have different layers to sync consensus blocks on one side and execution blocks on the other side. And the only reason we keep one inside of the other one today, I mean, today, this is an engineering problem that none of the layers are actually saving the full blocks. And if we want to serve nodes, we need to go through an API to get the payload, assemble the blocks, and serve them. And we're actually trying to get rid of this. So if anything, we want to separate the P2P stacks even more.
Right, I'm not up to date on that, but like, I mean, originally I thought we wanted to eventually deprecate lib P2P. Is that not like something that we're aiming for in the long term anymore? Sorry, dev P2P.
Yeah, I think that's true, but I think still like what we're hoping to do eventually is to have like the EL syncing on their side with dev P2P. But again, yeah, so this is sort of like a side to this meeting's discussion.
Right. Okay, so I guess like maybe we should do a temperature check. Like if we have the two options where one, we separate the two as I suggested in my proposal, we basically keep a somewhat cleaner abstraction between the two layers, but at the cost, obviously, of probably more latency on like the proof propagation. And option 2 would be we just bite the bullet and like say no, like we're just never gonna have like abstraction on that. The execution layer should just like produce and verify the proofs which one would people prefer? Maybe like everyone can write that in the chat. Because like I do want to make progress on this, and to me it's just not clear what like the what people's opinion on this is. Okay, so to repeat, sorry, yeah, go ahead.
Yeah, one thing that I don't particularly like either solution. One thing or the problem that I see with your solution of polling is basically or usually the deep transactions that make it into the block arrive pretty late into the block. So we usually mine the transactions, the good paying transactions quite late.
But that's true for normal transactions, not for blob transactions, right?
I think that's true for all transactions. We could just say, okay, blob transactions will not be mined after a certain time or something, or we could say, okay, they might have a UX difference between blob transactions and normal transactions, which is fine.
I mean, you can also accept that like the builder does still have to compute some proofs locally, and we just reduce it with this, right? So we can also accept that. Yeah. So yeah, I mean, also remember, like if builder builds at time 0 and like typically nodes get this after 1 second or so, they did have some extra time to compute the proofs as well. I don't know if it's enough, like, yeah, to get them and propagate them.
I think that the idea of saying like having some call like, give me the best 10 blob transactions that you have in your mempool and executing that at the same time as you build kind of before that, like we could kind of ask the CL asks the EL, give me your 10 best transactions. Once the CL knows, okay, the last, like I'm building on top of this, or like this is my slot now. And then we could, the CL could start computing this while we prepare a block in the background. And so it might just only need to like swap out 1 or 2, or like recompute 1 or 2 of the blob transactions proofs. Yeah, it makes sense to me.
Right. Well, what about option 2? You said you don't like either.
Yeah, the other one, it will increase kind of so in all of these things, we're kind of like limited by the bandwidth, right? And so if we increase the bandwidth even more by sending all of these transactions, I think it will be worse for the network. And there's no real limit on the number of block transactions that you send. And yeah, that's the one thing. And then you kind of need to do the proving or verifying of the proof, both on the CL and the EL. So you're spending these resources kind of twice. And every node needs to verify the proof. on every transaction that arrives. And so kind of transaction verification is one of the biggest things that we're spending CPU time on, which is weird in my opinion. But it's just we're spending a lot of time of our CPU time on verifying that these potential transactions that might make it into the chain are valid looking or valid. And if we add more time to that, that's not great in my opinion.
Right. Okay. I mean, this is actually something good to figure out. What is the time to verify those proofs? I don't have those numbers ready. You should probably get those. We know how much it takes to compute, but I don't know right now how much it takes to verify all of them.
Is this in a batch or are you verifying?
It would be batch, like it would be all proofs for one row.
Wait, was Marius talking about 4844 or was he talking about 75 PIRDAS verification?
It's PIRDAS. Like it's basically it's all the proofs for one row, verifying all the proofs for one row. That's what you would have to do every time.
Okay,
Justin just says he's going to look it up.
Ansgar, you have your hand up.
Yeah, just to point out though, right? Like because I think the problem of every node would have to verify a proof per block transactions that is true no matter which approach we choose, as long as basically like basically both in kind of Dankort's proposal and the kind of the variant if they travel throughout the entire network, they have to be verified at every hop. So if we think that is a problem in terms of CPU time and everything, and we also think that just the builder computing them is also a problem because of delay for propagation. I mean, the only third option we would then have to investigate would be somehow some sort of more complicated setup where the builder basically finds someone directly in their neighborhood, some individual kind of node that is willing to do that for them, or like something like a the relay offering a service like that or something. But then that would be a very different third type of solutions here, right? If we consider if we come to the conclusion that because of the computation time, both other solutions are unacceptable, then really we're kind of running a bit out of options for solutions here.
Well, with my proposal, the advantage would be that you could make it optional. Like you can choose just not to be part of that topic.
But then how do you actually? So you'd still basically forward the mempool transactions if you see them, even if your CL doesn't have the proofs for them, I guess.
Come again.
Yeah, no, I was just wondering. So basically, then you just accept that some nodes basically only forward the transactions on the mempool side without ever having seen the proof. Okay, that actually is an interesting trade-off.
Okay, Chaba, where did you get that number?
It was the verified proof in the benchmark on a P call, if I remember correctly.
Okay.
So the
yeah, that's a lot.
Yeah, but let me just double check.
Okay, we need to verify that because that might that might preclude certain options if we know that that's true. Then maybe it just doesn't make sense to like add all the proofs.
Well, but like, I mean, we already have to do this anyway after the block creation, right? So this basically, once we distribute samples, the sample proofs also have to be verified. I mean, of course, they're somewhat differently structured, and you only see a portion of the data and a portion of the proofs. But if that is something you have to be able to do in reasonable time, and like long term with mempool sharding and everything, we will probably have a similar portion of basically like any node in the network will probably see a similar portion of the overall data first travel to their mempool and then return back in the block propagation step. And so if you have to be able to basically spend the time to verify one, then you should also be able to do it on the other, or are there like specific DOS concerns because it's free to send transactions that fail that verification step?
Okay, Justin says it's 17 milliseconds.
But I think the 17 was the stable frequencies, which is not, I mean, it's okay if you are doing only that, but once your CPU is doing this and that, you don't get those.
Right.
That's how I remember.
Marius, is 17 milliseconds for verifying a transaction, is that crazy or is that possible?
I think that's crazy.
Okay.
Like right now at the boot nodes we get roughly 5,000 transactions per second that arrive there.
5,000 transactions
5,000
per second?
Yes.
Wait, but I mean, most of these can never be included.
Yes, most of them are not included. Also,
what are these transactions doing?
Math. Those were
Okay.
those are numbers from when like the math when the math wars were still happening on chain. So it might be less now, but at the peak it was roughly this. And so if we spend 17 milliseconds on verifying each one of them, and of course there were
that's only blob transactions.
Yeah,
this is only
normal
blob
transactions.
Yeah.
I don't know how many blob transactions arrive at a node per second.
Right, can't be that many.
I mean, we could in any case like rate limit them way more than that. Like, even if we scale much more, the target is going to be like 64 block transactions per slot, 128 block transactions per slot. So at most on the mempool, you should see like tens per second or something, or like it should be really limited to be at most tens per second.
Yes, we should maybe see one order of magnitude more than what we see on, or what we can include in a block. That's what I would guess.
Do we have data on, let's say, these same boot nodes, how many blob transactions they're seeing these days?
I can see, but I don't think we have the metric for that.
Okay.
Okay, so my expectation was always that most transactions that make it into the mempool will make it on chain. Like otherwise, like shouldn't we just be more aggressive on filtering transactions in the mempool and not let them in if they aren't paying enough? I guess transactions can be replaced, but don't we limit that as well and only allow it if like there's a significant increase in fee?
Yes, we need a 10% increase in normal transactions and 100% increase in blob transactions to replace.
So my mental model is that there shouldn't be really much more transactions than are included on chain. Like, so I expect if we have, say, 16 blobs per block, that there should be 16 blobs per slot in the mempool.
I think that's true for normal nodes. I think the issue with these boot nodes is everyone's kind of hammering them because they are very well connected in the network.
Yeah, I see. Okay, I think this is like an important new discussion point. So I guess we should definitely, because that was also like something. I mean, we did add the proofs. Like I do remember we had this discussion a couple of years ago where like we were discussing the blob transaction format, and like without the additional proof that we put in there, the verifying that the commitment was correct took about 30 milliseconds or something. And I do remember saying, oh, that's really bad, and that's why we added the proof. So I do wonder if we should, if this is enough to say that that solution is just not gonna fly. If every node now has to verify this for every transaction, well, I don't know. Is that too much? Like, let's say it's 10 transactions, so we're adding like 200 milliseconds or so in verification time. It doesn't sound that crazy to me, but I am curious. Like, what is the main argument that this is too much per transaction, Marius?
Sorry, what was the question?
My question is like, I am surprised that we're saying like these 17 milliseconds per transaction would be like a huge killer.
Well, I assume those benchmarks is like not on one core. It's like the whole
No,
machine.
this is
on core.
Oh, that's a good question.
It's on one core. So the 30 millisecond is on one core, not running on normal frequency, not on a toolbar frequency.
Yeah, this is
So into the task set to one performance core of that 12 generation.
Okay.
But I think to me the main questions are what are kind of the filters on the transaction. So one filter point is clearly when it gets to the block. And if you are doing proofs only after that, we understand that quite well. But whenever proofs are generated on transactions before they are getting to the block, what is the filter that we have there? And I've seen some filters put in here in the discussions, like how it's related to the base fee, etc. But we don't have a clear filter before that, so you might have to calculate in a lot of transactions. That just feels a bit undefined at that level.
So we kind of have multiple filter steps, right? Like we're checking the signature, we're checking like all of the basic stuff, and then we're starting with the heavy checks, and the heavy checks are looking after nonce. That is already really heavy, and then we need to verify the blob, the commitment to the blob, the blob proof, and then the question is like, and now we would need to verify this proof. Then the question is, if the blob proof is correct, then this is a correct transaction, just sent with the wrong proof. What would happen there? Would we need to compute the proof ourselves and then send
No, you could drop it.
transactions? Just drop it.
Yeah.
I think the problem is not when it fails the proof, it's too many transactions which are passing all your tests.
Oh, but yeah, I mean, I guess that's an interesting question. Like, I guess like Marius was saying, if we that we could have a DOS vector where you send this transaction, but with incorrect proofs.
Okay. Yeah, I see.
And now now it would mean that you can't yeah, but like anyone could now create those proofs and resend that transaction, and it would be a correct transaction. But I guess if nobody's doing it, then yeah.
Sorry, can you, like, are you saying if there is a normal transaction, like a good transaction, let's say, it's not the sender that is putting a bad proof, it's just someone is taking the transaction and attaching a bad proof to it?
No, I guess that's also possible, but I mean, it doesn't matter because you would still get the real transaction eventually. I don't know. No, I'm more talking about the situation where the sender sends sends the transaction already with a bad proof attached because, yeah, just in order to like make everyone waste some computation time.
But I mean, in this case, can't you just disconnect any peer that sends you such a transaction because it's provable that I mean they should have verified it and.
Right. Yeah.
Friends go.
Yeah, I was just wondering, basically a variant of this, what if we just do the stupid thing and basically allow transaction senders? I mean, again, would have to decide whether it's part of the transaction format. I think probably not that, but just basically some optional side thing that you can attach to the transaction, but that is signed by the sender, basically for proof. And then you just don't verify it. You just ignore it. You send it with on the mempool, and then it's basically just a hint for the builder, and then only the builder before block production verifies it. And if it's wrong, too bad, you just ignore it. And if it's right, you use it. And so basically that means the game theory is just, if you want to make sure that even if the next builder is a weak local builder and you still want to be included as soon as possible, you attach a proof, because why not? And if you don't care, you don't. And so basically that way we don't waste people's time with verification, but people will still be incentivized to do the right thing. And the failure mode is very harmless.
Right. It would have to be signed though, right? So that not someone else can't simply attach like incorrect proofs and make it fair.
Yeah. So that's one extra verification, but I assume a normal signature verification is much less overhead, compute-wise.
How do we have this at the moment? Is the wrapper signed in the current blob transactions?
It's not.
Right. So that would be a major change.
So I guess given that we only have 7 minutes left, do we want to try to define next steps? Or how do we make progress on the decision here?
Yeah, I mean,
on ACD.
we're kind of not really decided between the two yet. I see a weak majority for option 2, I think. Sorry, where is it? Can't see it anymore. I guess I don't know if that's still the case with the information of the time it takes to verify. I'm currently not completely sure if that's gonna work. I guess like maybe given this weak majority, maybe we should just specify this first and see what it looks like, and then see if client teams can work with that. I don't know. I can have a go at that.
That sounds good, but how do we address the verification issue that Marius mentioned? Do you have any steps to sort of solve this or figure out if it's a problem?
Okay,
Yeah,
Porto seems to integrate. Okay, do we want to have another quick vote? See if it changed. I'm gonna post option 1 and option 2 again in the chat, and then we see.
But aren't we
what
just talking
people-
about how to structure the API calls, basically? So I don't see why, like, the performance will be the performance regardless of where it lives, right?
Yes. The advantage of my option is that you can, like, that not everyone has to participate. So if it's a problem for anyone that the CPU that this uses, it would be they could just not subscribe to that gossip stuff. I agree with your point that it's like less clean on this ultra peer question, but it's still not an ultra peer. Like it doesn't require anyone to subscribe to all sample topics, for example.
Okay, and so option 1 here is saying some sort of polling architecture where the CL is getting blobs from Mempool and then computing proofs. Okay.
Yeah.
And then that would still be to gossip them, or I guess that's what I was confused about. If we're talking about your gossip proposal or just how we're actually structuring this.
We're still gossiping, yes. So we're gossiping, and then like when you receive a block, now anyone with the proofs is able to create for their particular columns the complete proof at like very low cost, because they have the proofs anyway from gossip. All right. Given that Ansgar says this, should we maybe like we need someone to champion each option and like think further about this? Like I'm happy to keep working on option 1 and think about all the things. Does anyone want to take option 2 and like basically think about how it would work and what the mitigation for that for the computation is? Okay, great. We have Ansgar as a champion for option 2. Cool. Okay, I think we're almost at time. Any other comments on this? Does anyone want to bring up any other concerns or ideas? Are we generally like going in this direction? Does to everyone feel the right direction, getting rid of the previous ultra peer ideas, which is basically what this is? Would anyone rather go back to our previous designs?
I guess I did have a question. Like, were we still discussing? Because I think where this originally came from was just the fact that it was taking too long to make the proofs during building. So even aside from like having some other peer compute the proofs, do we want to explore designs that would pipeline this a bit better? Just so that, you know, you could imagine building locally yourself in any case.
What do you mean by that? I mean,
like
doing the building yourself is always an option, right? You can always just like, I mean, you might as well, after you've sent your block, compute the proofs and send them in case nobody else has done it.
Okay.
So I feel like I mean,
so then
we
the
might as
gossip
well
part
specify.
is just to like add some redundancy.
The gossip part is to reduce the latency on this, so that like the proofs are already ready. You don't need to compute them. So this also helps, like even if you are a self-builder and want to distribute them all yourself, this also helps you with proof computation, because you can just listen on that gossip channel and just be like, okay, I have all the proofs. So I don't need to do the computation locally, only the distribution.
One thing that I worry a bit about is like, so we said 6 kilobytes for the 128 of blob, but then you add the gossip overhead, and compared, which we wouldn't really have in the EL, because the mempool is pool based, and it ends up just, I don't know, it ends up being like a much bigger bandwidth factor.
Right. So we're saying we get a factor of 6, right? So it would be 36 kilobytes.
Well, but the nice thing at least is now, if only basically more powerful nodes opt into this gossip into the subnet in the first place, right? Those are probably, I mean, we would assume that there's some amount of correlation between nodes that have extra CPU to spare and extra bandwidth to spare, right? So maybe that kind of just works out.
But like you also need proposers to, like, I mean, the whole thing is for local block building. So generally you do want people to, at least when they're proposing, be able to subscribe.
Yeah, I mean, if we're worried more about average bandwidth and peak bandwidth, then you could simply like subscribe to it whenever you're building the block, right?
Well, and for basically the concerns about peak bandwidth and then the builder bandwidth specifically, that really is something we have to discuss in the context of the mempool in general, right? Because, I mean, at least for now, we still assume that the builder has to have all the blobs local anyway for those transactions they're about to include. So that then, yeah, basically already that causes big challenges.
Right. Okay, cool. I think, oh, Potos, you have something?
No, I'll ask you off. I'll ask you after.
Okay, cool. So we're over time. Thanks everyone for the call. I think that was at least helpful in terms of knowing like what we're doing next. Hopefully, like on the basis of more detailed proposals, we will be able to make more progress next time, and hopefully have a decision. But yeah, thanks everyone for joining. Bye bye.
Thanks.
Take care. Bye.
Thank you.
Bye.
Thank you.